Today we're going to talk about antidifferentiation by substitution. I know we started to talk about this last week, but with all the distractions and interruptions, I thought it would be better if we just started from the beginning. If you feel like you don't need to watch this part of the video, feel free to just skip ahead until you find something new. Antidifferentiation by substitution, or integration by substitution. An indefinite integral of f with respect to x is the family of all antiderivatives of f and is denoted by notice that an indefinite integral doesn't have a number here or here. That's what makes it an indefinite integral. That means that instead of finding an actual value as you integrate the function, you are simply finding a formula that somebody could put numbers in later to calculate the area under the curve. Now what we're going to do is we're going to make a list of some different integral formulas that will help you stay organized, have them all in one place. And we've done a lot of these before, but now they'll all be sort of all in one place. So the first one we have is a power formula. The integral of u to the n du equals u to the n plus 1 over n plus 1 plus c. This is where we said you take the exponent, you add 1 to it, and then you divide by the new exponent. Don't forget your plus c, because this is an indefinite integral. Anytime you have an indefinite integral, you have to have plus c. Okay, here's the next one. This one's a little sneaky. The integral of u to the negative 1 du. Let's think about what that really is. Doesn't that equal the integral of 1 over u du? Or you could even say that equals the integral of du over u. I don't really like this particular form, but it doesn't mean that you're not going to see it printed somewhere. So if you remember, whose derivative is 1 over x? ln x, or in this case, ln u. Now, it's very important here that when you evaluate this integral and you get ln u, you must have absolute value bars around the u. The most important thing you can do is to remember to put them there. The reason you need them is because, if you recall, the domain of ln x does not include any negative numbers or 0. So by evaluating the integral of 1 over u, you have to tell the person who's going to put in numbers later that they're not allowed to put in negative numbers. They will have to make them positive. And that's what the absolute value bars will tell people. Now we're going to make a list of some trig integrals. Again, you're going to know most of them, but it is nice to sort of have them all in one place. Okay, so here we go. The first one is sine. So the integral of sine u du, and they're just using u as a generic variable. It could have been anything. They're just choosing to use u. So the integral of sine u du is negative cosine u plus c. Again, don't forget your plus c. If you're not sure, or if you temporarily disagree, try to take the derivative of negative cosine u. The derivative of negative cosine u is going to be positive sine u, because the derivative of positive cosine is negative sine, but this is already negative. Okay. So next, the derivative of cosine. Can I take that back? The integral of cosine u du is sine u plus c. the integral of secant squared u du. Whose derivative is secant squared? That's right, tangent. Don't forget your plus c's. The integral of cosecant squared u du is negative cotangent u plus c. The integral of secant u tangent u du equals secant u plus c. And last one, the integral of cosecant u cotangent u du is negative cosecant u plus c. Okay, next on our list we have some exponentials and logs. The integral of e to the u du equals e to the u plus c. E to the u is one of those strange little expressions whose derivative and integral are exactly the same. It's weird, but it's true. What if it's not an e? What if it's some other number? The integral of a to the u du is likewise a to the u, just as it is e to the u over here. But if you remember, even when we take the derivative, we have to do something else. When you take the derivative of a to the u, the derivative of a to the u is a to the u times ln a. Because we're going backwards and taking the integral of a to the u is going to be a to the u divided by ln a. And of course, don't forget your plus c. It'll probably take some practice and maybe even some memorization to remember these, but you got to do what you got to do. Okay. This one, look, I'm writing it down because it's in the book, and I guess they think you need to know it, but I got to tell you, I never recall having had to cough that one up. But put it down anyway. Might come up in your homework problems. And then we have a similar version, but with a generic log instead of the ln. So that's pretty similar to this one as well. But just like the one on up here, this is going to have to be divided by ln a. And don't forget your plus c at the end. If you hear any strange noises in the background, my husband is redoing our kitchen, and although I've tried to get as far away as possible, you can still hear saws and air compressors in the background. So, sorry, but hey, I can keep you updated. Okay, let's have our first example of true antidifferentiation by substitution. Okay, so here we go. We have the integral of sine x times e to the cosine x dx. Okay, when you were learning differentiation, there were all of these rules you had to remember. There was the product rule and the quotient rule, the power rule, the constant multiple rule. There were all of these rules. These rules just don't really work with integrals. So even though this is a product, there's no product rule. So you have to use what are called techniques of integration. And one of these techniques is substitution. Okay. In the beginning, I'm going to tell you what to substitute until you get good at it. What we're going to substitute here is this cosine. Now we know that the integral of e to the something is e to the something. So we're going to use that to our advantage. So what we're going to do is we're going to come over here to the side, and you'll do this too, and you're going to say that u, oh, that's not what I wanted. U equals cosine x. The u is generic. You could have chosen anything, but usually if you're going to do some sort of random substitution in math, they pick u. That's just what they do. Okay, the next thing you have to do is take the derivative of this, because dx right here no longer just means dx. So this dx has to get replaced with a du because you can't have multiple variables in this integral. So if we take out this x right here and substitute it with a u, then we can't integrate with respect to x because that won't be an x anymore. Those are now bothering me. Okay, let's move back over. Now it's blue. Okay, well, you can get over that. So the derivative of u is du dx equals, and what is the derivative of cosine? Negative sine. The difference here, the only difference between like sort of a normal derivative, is that we don't want this dx here. We really want it over there. So we're going to say that du equals negative sine x dx. This truly is, you're multiplying the other side by dx because it was divided on the left. I know we never really thought about it that way before, but time to think about it that way now. Okay, so if you look over here, I see a sine x, and I see a sine x here. Okay, so watch what we're going to do here. I need to make this bigger. I can't make it bigger. Okay, forget that. I'll just shrink it. So u is going to go in for cosine x. So right here, I'm going to take this cosine here, and I'm going to replace it with u. It's going to make my life easier, I promise. So this is going to be e to the u. Okay, but the problem is I can't integrate this with respect to x because it's not an x. So that's where this stuff comes in. So du is going to replace sine x dx. Now come and look up here. I see sine x dx. It's not next to each other, but hey, this stuff is just all multiplied together, so it doesn't matter. So sine x dx is going to get replaced with du, except we have to account for this negative. But that's okay, because you can fudge the numbers. So what I do is on this derivative, the first thing I do after I say du equals whatever, I look over here and I say, is what's here, is this somewhere over here? It is, except for this negative sign. So what I do is I take this negative, I put it on the other side. Or if it's a 6, I would put a 6 on the other side. So negative du equals sine x dx. So now it's a direct substitution. So I can take out this sine x dx and replace it with negative du. So that's what I'm going to do right now. So I have my e to the u, that's still there, and I have negative du, but it's really times negative du. So I'm going to put the du there, and I'm just going to stick the negative out front because I can do that with numbers and negative signs and integrals and in derivatives. I can just throw that stuff out front. Now we're ready to integrate e to the u. But what's the integral of e to the u? E to the u. Isn't that lovely? The negative is just going to drag down. Don't forget your plus c. Okay. The final step, which is very important, is to substitute back in at the end. Nobody actually cares what u is because you made it up. So you have to take cosine x and you have to sub it back in there at the end. So our real answer is negative e to the cosine x plus c. Okay, let's try another one. Okay, we're going to have the integral of x squared times the square root of 5 plus 2x to the third dx. Just got a lot more complicated, huh? Okay, it can be difficult in the beginning to try to figure out who you want to make u, but as I said before, you do get better at it. So I'm going to start by just telling you what you should be. Okay, we're going to make u the stuff that's underneath the square root sign. The trick is you don't want to make the u too difficult because then you just make a mess out of the derivative and, well, the end of the story is it just doesn't work. So, but you don't want to make it too simple either. It's got to be difficult enough to help you, but not difficult so much that it's unmanageable. Okay, so we're going to take just what's underneath the square root sign and make that u. We're going to continue over here by taking the derivative of u. So the derivative of u is du equals, and that's going to be 6x squared dx. So I just skipped the step of having the dx on this, on this side, and I just left it on the other side, so I'd have to write a little bit less. So now look at what your du is. Come over here. Do you see 6x squared dx in the original pink problem? Well, almost. I see x squared dx. I just don't see the 6, but numbers can be fudged. So let's come back over here. What I'm going to do is I'm going to divide both sides by 6 and get that 6 on the other side. Then it'll be a direct substitution. So 1/6 du equals x squared dx. And now this is going to allow me to directly take x squared and dx and replace it with 1/6 du. So now I'm ready to rewrite my integral. I'm going to take this 1/6 and I'm just going to put it out front because it's going to get in my way. And then the x squared and the dx is getting replaced by the du with the 1/6, but I already have that there. And then the function that's in the integral then is just the square root of u. And look at how much simpler you just made that. This was a mess. This is adorable. Okay. However, we are going to take the square root of u and make it u to the 1/2 so that we can apply our power rule. And then just dragging down the 1/6, I'm going to add 1 to u's exponent. That's u to the 3/2. I'm going to divide by the new exponent, which is 3 over 2. But of course, that's a mess, so I don't actually really want to do that. So instead, I'm going to multiply by 2/3. Don't forget your plus c. Okay, so I'm going to clean it up a little bit. I'm going to make this a 3 down here. So now that's 1/9. And now I'm also going to sub back in the u. Remember, you made u up, so nobody cares what u is. Come back up here. U was 5 plus 2x cubed. So that's what we're going to sub in back down here. 5 plus 2x cubed to the 3/2 plus c. And as I'm sure you can tell, this is going to take some practice. Okay. That's the end, I believe, of where I got to in your classes last week. So right now it's time to start a new problem. I do not remember doing this one in class with you guys, so this one's going to be new. Okay, ready? We're going to have the integral of the cotangent of 7x dx. I have so many issues with this. I mean, like, where are we even going to start? Cotangent. All right, let's come back up and let's look at our trig formulas. Do you see cotangent anywhere over here? The only place I see it is right here, and I don't have a cosecant, so this is not going to help me. Bummer. Let's come back to the bottom and take another look. Is there anything we can do with cotangent? Anybody got any ideas? I'm hearing crickets. Okay, so let's change cotangent into cosine over sine. You thought that was going to go away after pre-calc, didn't you? You silly people. Okay, don't change the angle, so the angle is still 7x. And this is all with the dx on it. Okay, so you have some options here. If you've noticed from the ones before, the way to pick out u is to see if u's derivative is somewhere in this integral already, because that's the only way that this works. So now cosine and sine are each other's derivatives in one form or of another, but sine is on the bottom. The derivative of sine is cosine, and that's on the top. So what I really want to make u is sine x, because the derivative of sine is sitting right here. And that's a good thing. So that's what you want to look for. So let's come over here. Well, I did it again. du equals cosine x dx. Oops. I'm gonna run out of space. It's not letting me. There we go. Okay. I made a mistake. I'm so sorry. Let's take this out. I'm gonna move this over because now I ran out of space. Let's move that down here. Okay. Sorry about that. U is not sine x. U is sine of 7x. Okay. So du is cosine 7x dx, but don't forget to multiply by the derivative of the angle because that's the chain rule. Okay, so now what you want to do is look in your integral and see if you can see this. So let's look over here. I definitely see the cosine 7x dx. That's here, right? But I don't see the 7. But remember, we can fudge the numbers. So let's come back over to our derivative. We're going to divide both sides by 7 and get 1/7 du equals cosine 7x dx. And now it'll be a better substitution. So now I can take all of this out and I can replace that with 1/7 du. Okay, now u is sine of 7x, correct? And where is sine? Sine is on the bottom. This turned into du, and sine is on the bottom. So this is really the integral 1/7 times the integral of 1 over u du. So you got to be careful that you don't just put the u on the top because it's not. It's really on the bottom. So you have to pay attention. Excuse me. Okay. 1/7 times integral of 1 over u is ln u. Don't forget your absolute value bars plus c. Recall that nobody cares what u is. 1/7 ln of sine 7x plus c. And that's our answer. Good job, I guess. Wish I could see you. Okay, let's try one more. Integral of dx over cosine squared of 2x. Cosine squared. I'm already annoyed. I don't know what to do with that. I also don't like this dx on the top. It really bothers me. I'd rather them just put the dx like out here and put a 1 up there, but whatever, I can't stop them. Can anybody see some trig we could do with this to make our lives easier? What is cosine in a denominator? It's secant. So this could all be changed into secant squared of 2x times dx. Now, I know the integral of secant squared, so that's good. But look at this 2x in there. That's no good. So that's who I'm going to make u. This is going to be a pretty easy substitution because it's really just a number. And if you find you could even skip this step and not do this whole u substitution over here, that's totally fine. But you need to have a backup plan if for some reason, it's not going to work. Okay, so over here, we're going to change secant squared 2x into 1/2. And then that's going to be secant squared of u du. Because the only thing I made u was 2x, so then that's the only thing that's going to get substituted. So if I integrate secant squared, of course I get tangent u. Don't forget your plus c. And then at the end, don't forget to sub back in. So 1/2 tangent of 2x plus c. Very good. Next time, we'll do substitution with definite integrals. But for today, that's good. So make sure you check the calendar or Teams for your homework assignment, and we'll catch up tomorrow with any questions.